Last time we talked about what happens, what's true about certain angle pair relationships when we know our two lines cut by a transversal are parallel. Today we're going to look at doing that backwards. We're going to look at, if we know about the angles, how can we prove that the lines are parallel? So all of these, we have a postulate and three theorems. They are all converses of what we did last time. So remember, a converse switches the if and then part of our statement. So all of these start with two lines cut by a transversal and some congruent angles. And then all of them end with, then the lines are parallel. So let's go ahead and write out our postulate and our three theorems, and then we'll get into actually applying these. So the converse to the corresponding angles postulate is that if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So we're not going to go through the figure for each of these theorems below, but we will do it a little bit for this one. So if we have one pair of corresponding angles that are congruent, then we know our lines are parallel. So if we know if angle 1 is congruent to angle 5, then these don't have names. Let's name this one L, this one M, and this one T. So if the two corresponding angles are congruent, then we know L is parallel to M. So moving on to the converse to the alternate interior angles theorem, it's almost all going to be the same. The only thing that's going to change is right here. Instead of corresponding angles, we'll say and alternate interior angles are congruent. So, if two lines cut by transversal and alternate interior angles are congruent, then lines are parallel. So I'll circle the important part on each of these. So for the converse to corresponding angles postulate, corresponding angles are congruent. For converse to the alternate interior angles theorem, alternate interior angles are congruent. Now remember, the same side interior angles for this next one, that's the one that's different. So if two lines are cut by a transversal, and same side interior angles are, remember last time, these weren't congruent, they were supplementary. So if we know they're supplementary, then the lines are parallel. So always keep in mind that same side interiors are the weird ones because they're supplementary instead of congruent. And then our last one, converse to the alternate exterior angles theorem, same thing, but alternate exterior angles are congruent. So two lines cut by a transversal and alternate exterior angles are congruent, then lines are parallel. So, since all of these are converses, like I said before, this is exactly what we did yesterday, but backwards. Yesterday we knew the lines were parallel, we proved the angles are congruent or supplementary. Now we're doing, we know the angles are congruent or supplementary, so we can prove the lines are parallel. So here we've got two pairs of lines. So if we look at lines A and B, we've got a transversal there and a transversal there. If we look at lines C and D, there's a transversal there and a transversal there. So it's kind of an interesting picture. For number 1, if we know these two angles are congruent. Now, since we're looking at angles 1 and 2, it does not include line A at all. So we don't even look at line A. Which two, first of all, what type of angles are those? They are corresponding angles. And if we know they're congruent, then we know that which lines are parallel. Well, that's C and D, because their names are right there. So we totally disregard line A in that problem. Now for number 2, we've got angle 2 and angle 6. So that means we don't need line C at all. Those are alternate interior angles. And that shows us that A and B are parallel. For number 3, we've got angles 1 and 5. It says those add up to 180, so they are supplementary. We don't need line D because it's not part of any of our intersections. So again, that's going to be A and B. Those are same side interior angles. And same side interior angles, again, are the oddballs. They're the ones that are supplementary instead of congruent. And then finally, if we know that 8 and 3 are congruent, we can get rid of line D again because it's not involved in either of those intersections. And there we have alternate exterior angles. And so that makes lines A and B parallel again. Now, once we get into these type of problems where we're finding angles or solving for x, the nice thing is we do this exactly the same way we did it yesterday. The difference is that yesterday the question was, if the lines are parallel, what is the angle? And now the question is, what angle would make the lines parallel? But as far as practical work, it's going to be the exact same thing. So here on number 5, we've got some corresponding angles. We know those need to be congruent, so it's got to be 58 degrees. Number 6, these are alternate interior angles. We know those need to be congruent, so this one is 111 degrees. Number 7, we've got some same side interior angles. We know those are supplementary. So we have unknown plus 74 equals 180. So our unknown angle is 106 degrees because they have to add up to 180. And then on number 8, these are alternate exterior angles. And so they need to be congruent. So it's also going to be 84. So when we're just dealing with the numbers, it's pretty straightforward. You either have the same measure or a supplementary measure. Now for these last few, we'll actually have to do a little bit more work because we're solving for x on these. On number 9, we've got corresponding angles. Those are congruent, so we set them equal to each other. 12x plus 4 equals 64. 12x equals 60, so x is 5. Number 10, these are alternate interior angles. Those are congruent. 6x plus 4 equals 5x plus 15. Move all our x's to the left, move all our constants to the right. And in this case, we don't have to divide because we only have one x, and it is equal to 11. On number 11, again, same side interior. Those are supplementary. X plus 91 plus 95 equals 180. So that's x plus 186 equals 180. So x equals -6. Remember, it is okay to have a negative value for x as long as when you plug it back in, you get a positive value for your angle or your segment measure. And if we plug that in, we'd get 85, so that's fine. It's definitely not a negative. And our last one, number 12, alternate exterior angles. Those are congruent. So again, we set them equal to each other. X plus 81 equals 70. So X is negative 11. Again, negative numbers for X are definitely okay as long as we plug them back in and we still get positives. So that's it for this lesson. If you have two lines cut by a transversal and you know that corresponding angles are congruent, or alternate interior angles are congruent, or alternate exterior angles are congruent, or same side interior angles are supplementary. If you know any of those four things, you know your two lines are parallel. So do those practice problems, check over your work. Please ask questions if you have them. Get ready for that mastery check. Good luck.